Define the resultant force. The resultant force is the single force that has the same effect as the other forces together. You need to talk about force. You can't use the word result to define resultant. You need to use things like same effect. The normal force is a force perpendicular to the surface. It is a reaction to the force applied to the surface by the object. Explain the concept of inertia. It is the tendency of a body to remain in a constant state of motion, so either staying still or at a constant velocity. Newton's third law states that for every action force there is an equal but opposite reaction force. What is the reaction force to each of the following? The weight of the man standing. Remember what weight is. Weight is the attraction of any body to the center of the earth, and therefore the reaction to that is the man attracting the earth. And then the attraction of a north pole to the south pole of a magnet is going to be, the opposite force of that is the south attracts the north pole of a magnet. Now we have to draw free body diagrams. Firstly, it is ideal to use a ruler for each of them. I'm not, because you can't on a device, but anyway. A car is traveling on a level road at a constant velocity. I put a dot there. I give each of these names their full name. You can either write weight or gravitational force. And gravitational force is preferred. Equal but opposite is a normal force, holding it up. Pushing it forward must be some sort of applied force or driving force. Keeping it at a constant velocity, exactly the same length, must be some sort of a frictional force. Next one, a ball is at the top of its projectile after having been thrown upwards. This was straight out of your notes. When it's at the top of its projectile, it obviously has a gravitational force downwards. It is not moving, so it has no air resistance. It's not in contact with the surface, so it doesn't have any normal. It's just the gravitational force that is being applied to it at the point at the top of its projectile. Parachutist is coming down at constant velocity. Again, we've got a gravitational force. And then it's a constant velocity, so there must be an equal but opposite force in the opposite direction, and that is air friction, or air frictional force, if you prefer. Then you're going to have a bullet that has just left the barrel of a gun. Firstly, it has, again, a gravitational force. And obviously that bullet is actually on a trajectory. Sorry, let's make the bullet have a circle. There we go. That bullet is actually on a trajectory downward like this. That means it experiences air resistance, and the air resistance arrow is small, but it goes up towards the top left. If my bullet is moving, has been projected out towards the right, but towards the right there is no force. And finally, we have a brick on an inclined plane, a brick that is stationary on an inclined plane. So there we go. I like to put the inclined plane in as a set of dots just so that I know where it is. There is a gravitational force. And then there is a reaction to the surface, which is a normal force. And then it is being held up the slope by a frictional force. Next three calculations are fairly quick and easy. What is the magnitude of weight? Weight is mg. So it's F little g equals mg. Substitute in the 25, substitute in the 9,8, and you land up with 245 newtons. And I didn't mark you down, but later on you will get marked down. Weight, it doesn't say the magnitude, oh it does, it's just the magnitude of the weight, but if it doesn't say the magnitude, you also have to say down. But in this case, it did not say the magnitude of the force, so you do not need to say down. But be very aware of whether it's asking for magnitude or just the force. If an object with a mass of 150 kilograms stands still on a horizontal surface, what is the normal force exerted by the surface on the object? So the normal is always a reaction to weight. In horizontal, that is very easy. So Fn is going to be equal to Fg because it's just an up-down motion. Well, not lack of motion, rather. So that's going to be mg, which is equal to 150 times by 9,8. And this time, they don't say magnitude, so you really should have given a direction of upwards. Next one, 32 kilograms is at rest on a rough horizontal surface. The coefficient of static friction is given. What is the maximum static friction? So because it's on a horizontal surface, Ff is equal to mu Fn, and Fn is very easily equal to Fg, so it's just 0,24 times by 32 times by 9,8, and you land up with 75,26, and newtons is the unit. Don't forget your units on all of these. Last question. A 49 kilogram crate remains at rest on an inclined plane that is at 17 degrees. So 17 degrees over here. There is a weight acting downwards. They say it's a 49 kilogram crate. So if G equals 49 times 9,8, which is going to be equal to 480,2 newtons downwards. Then I would have had I can break this up into its components. This component is equal to the normal and is going to be equal to, well, let's get to that in a second. So it's going to, I've got two parts. There's a normal force and a frictional force, and then we have got a force acting up the slope, and that's going to be equal to that component over there. We've got 90 degrees between the two components and 17 degrees over here. So now I can label my triangle. That's my adjacent side, that's my hypotenuse, that's my opposite side. So if I am, first question is determine frictional, which is going to be my opposite, so I'm going to use sine, and I'm going to say if, let's rather use my color, if F is equal to the gravitational force on this object, but the parallel component, in other words, the component that is parallel to the slope, and then that is going to be sine 17 degrees is equal to the parallel component divided by 480,2, and therefore the frictional force is going to be equal to 140,4 newtons. Now looking at my normal force over here, my normal force is going to be equal to the component of weight that is perpendicular to the slope. So this time its cos of 17 degrees is equal to my adjacent over the hypotenuse, and therefore my normal force is going to be equal to 459,22 newtons. Finally, it asks me to work out the coefficient of static friction. So I now need to say that mu is equal to the frictional force divided by the normal force, because on your information sheet it said the frictional force is equal to mu Fn, and therefore that is equal to 140,4 divided by 459,22, and that is equal to 0,31.